So if I do 180 plus 30, that's at 210. And my x is square root of 3 over 2, and my y is 1/2, except they're both going to be negative. So it's actually the same values that we saw before when we were looking at 30 and 150, except now they're both negative. So then I'm going to go to 45. And I'm going to say, okay, the x is square root of 2 over 2, the y is square root of 2 over 2, but they're both negative. And then lastly, for our 60-degree angle, 60 plus 180 is 240. So at 240, I'm going to the left 1/2, going down square root of 3 over 2, so they're both negative. Negative 1/2 and negative square root of 3 over 2. Are they still the same when I look at those 30-degree angles? Yep, they're the same except the negatives. When I looked at the 45-degree angles, yep, they're the same except for the negatives, and same is true with the 60-degree angles. Okay, we are so close, guys. Let's just slide on over here. Oh, sorry, are you finished? You good? Last thing, what is going to change as we go into the fourth quadrant? In the third, both were negative. But in the fourth, x is back to being positive, but the y is still negative. So now, when I do 330, that's going to use a 30-degree triangle here. When you do your triangles, always make sure you use the x-axis. Don't use the y-axis. Always use the x-axis. Here, the x-coordinate is square root of 3 over 2, and that's going to be a positive because we're to the right. But we're going down 1/2, so that's a negative 1/2. When I go to the 45 angle, 360 minus 45 is 315. We're going to the right, square root of 2 over 2, but then we're going down square root of 2 over 2. And then 360 minus 60 is 300 degrees. We're going to the right 1/2, but then we're going down square root of 3 over 2. And once again, all the 30-degree angles are matching up. These guys are all the same. The 45-degree angles are matching up. They're the same except for the negatives. And the 60-degree angles, the same except for the negatives. So when I look at my big picture here, I can see that this blue rectangle here, we're going to have the exact same coordinates. It just goes x is negative, both are negative, y is negative, positive. For the 45-degree angle, they're all going to be square root of 2 over 2 for both the x and y. It's just negative or positive depending on the quadrant. And same with your 30-degree angles right here. So do you see how those rectangles match up? Okay, so guys, this is how you fill in your unit circle. And I'm going to have you guys practice this each class for the next few classes. I'll give you a blank one, and you fill it in. Does it make sense how to fill in the degrees? Yeah, that should be pretty make sense. The radians we talked about last time, and we saw an example there. And then once you get your first quadrant, you can actually just copy it over like this, and just make sure you put the negatives in the right spot. Okay, I'll show you an example of how to use a shortcut, but I want you to use the triangles at first so that you understand why we're getting the values we have. Does that sound good? Okay, now for this last part of class, I'm going to show you why we even care about this, okay? Do you remember, it was either last year or a couple years ago, when did you guys talk about sine and cosine? Last year you learned SOHCAHTOA?
Yeah.
All right. Now what we want to do is we want to take the sine of these different angles. And the angles could be in degrees and radians. So I want to do the sine of 30, or the cosine of 240, or the sine of 5 pi 6, or the cosine of 7 pi fourths. And that seems like it would be something that's really hard to do. But if you have your unit circle, it's actually really easy. Here's what I want you to do. Put a little note on here. all of our angles have been written like this. We put the x, or all of the coordinates have been written like this. We put the x first, and then the y. Well, that x is actually the cosine of whatever angle we're looking at. And the y, that is going to be the sine of whatever angle we're looking at. Remember what we call this circle with the line through it?
Theta.
That is theta. Good job. So let me show you an example, and then you're going to be so happy because it's going to be so easy, okay? Let me switch over to the example. So go back to your notes, but keep your unit circle close. So this is where I filled it all out. Okay, so let's say that I was asked to find the sine of 135 degrees. How do we do that? Well, you guys have your unit circle? Go to 135 and tell me what are the coordinates at 135. Jade, what is it? Okay, these are the coordinates at 135. We all agree with that, right? Now, what did I have you write on top? What does the first one represent?
The cosine.
That would be the cosine of 135. What does the second one represent?
The sine.
Now, were we asked to find the sine or the cosine? We wanted the sine, so it's going to be that number. So the answer here is just square root of 2 over 2. All you had to do was find 135 on your unit circle, and it's the y value because that represents sine. And then that's it. Isn't that great?
Wow.
Done. The hard part was filling out your circle. Once the circle's filled out, then it's easy. Okay, let's go to cosine of 300. So Antonio, look on your circle. What is 300's coordinates? Do you guys agree that those are the coordinates at 300?
Yes.
Now we want to find the cosine. So is that the x or the y, Antonio? That's going to be the x. So I'm just going to go and say, oh, it's this one. So I'm going to put in, that's 1/2. Now, can I show you that this works? Do you have your calculator?
I believe you that it works.
Go on your calculator. First off, do you see right by the blue button where it says mode? Click on mode. And make sure it's in degrees. You'll see it has the options between degrees and radians. And you're going to practice switching between those. But for now, be in degrees.
How do I close it?
You push second quit. So second mode quits out. So second quit.
Okay.
Now, put in cosine of 300. Does it give you 0.5 or 1/2?
It gives me 2.5.
Which is 1/2. So that means you did it right.
I believe you.
It works. All right? Now, this is going to be what you're doing on your homework. Let's go through and we're going to do some easy examples and do some that are a little more challenging, but really, it's just this. You find the angle, sine is y, cosine is x. Okay? And I apologize that on your notes these are written kind of small. You can't even really read it because it was in red and it didn't print very well, so I'm sorry. So you might need to write it in. But let's go fast here, okay? 240. Skylar, will you tell me what are your coordinates at 240?
It's negative 1/2 negative 3.
Square root of 3 over 2, right?
Yeah.
Okay, now if we're doing cosine, which one of those do we want?
Wait, what is the angle there? 240? The negative 1/2.
There you go. Yeah, so that's, sorry, I'll write that bigger. That's 240 degrees.
Okay.
And so Skylar told us the coordinates. We're doing cosine, which is the x. So I'll just plug that in. And if you want to check it on your calculator, putting cosine 240, it'll give you negative 0.5, which is negative 1/2. Nice. Thanks for your help. Let's go to Isaac. Number 2, we're doing 150. What are the coordinates at 150 degrees, Isaac?
Negative square root of 3 over 2 and 1/2.
Negative square root of 3 over 2 and a positive 1/2. Great. If I'm doing cosine, which one do I want of those?
Negative square root of 3.
The x one. There's your answer. Now that one's a little harder to check on your calculator. What you would do is plug this in and see what the decimal looks like, and then do the cosine of 150 and see what the decimal looks like, and it should look the same.
Is that why it's not giving to me when I say turn it fraction? I keep doing active.
Yeah, because the fraction converter doesn't work for irrational numbers.
Yeah, I keep telling answer fractions like this
Yeah.
is a decimal. I'm like, oh,
Nope, there's
fraction.
not an easy way to do it. All right, Luis, help me on 270. What are your coordinates at 270?
Okay.
Awesome. If I'm doing the sine, which one of those do I want? There you go. You can check that if you want. Okay, I'm going to skip 4 because I want to get to some other ones. But are you getting the hang of this? Sorry, that was 270 if you couldn't read it.
Yeah. Like, if I can see the angles.
Okay.
The next ones are I cannot see them
The
at
next
all.
ones are in radians. So let me write them out for you first, so before I forget. This is pi halves. This one is 5 pi fourths. And this one is 11 pi over 6. All right, Ruby, help me with pi halves. What are the coordinates of pi halves? If I'm doing cosine, which one of those do I want? So look back, or well, I had to write it down. I don't think I wrote it here. Your x is going to be the cosine, and the y is going to be sine. So if we're doing cosine, it means we want the x value, which is 0. Now, for you to check this on your calculator, notice you're in radians now. So what are you going to need to change on your calculator?
To the decimal?
The
So-
mode. So I want to walk around and make sure everyone's got this. You know where the mode button is? It's right by the blue second button. Change your mode to radians, and then push second mode to quit out. And then put in cosine of pi over 2. The pi button is above, it's above the caret button, which is by divide.
The caret button?
Yeah, that's what the exponent button is called. That means caret.
Huh.
I don't think it's spelled like a carrot that you eat, but that's it.
The
So
clear?
Jade says she put in cosine of pi halves and got 0. Can someone confirm that?
1 second.
Okay, I heard someone say yes.
Calculator no bueno. But if it isn't in radian, then it messes with everybody because using it.
So this is going to bring up a really important skill. You always check your mode.
Yeah.
Because people will get these really funky answers, and they're doing everything right, but then it's just in the wrong mode, so it gives them the wrong answer. Let's do 2 more. 5 pi fourths, all right? What are we going to do with that, Brian? What are your coordinates at 5 pi fourths? Is that at 5 pi fourths? I think you're looking at one of the other ones. Oh, I think that might, so those should be 2. So it's a negative square root of 2 over 2. So just change those on yours. But yeah, that's the right spot. We just copied it down a little bit. Huh? But there we go. In this case, guys, does it matter if we choose X or Y? They're
No.
the same. But if it's same sign, what do we want?
The Y.
The Y.
So that one I could get away with not knowing it. Pass.
Yeah. But only on a couple of them. Alright, 11 pi 6. I'm going to do the coordinates right here. I believe this is just square root of 3 over 2 and negative 1/2. Is that correct?
Yeah.
If I'm doing cosine, what do we want, guys?
Negative 1/2.
X
Oh,
or the Y? Cosine is the X, which is square root of 3 over 2. Okay, do you feel like you could do these problems on your homework?
Yeah.
You just need to say is it X or Y. Now, let me show you. I could make it just a pinch more difficult, but not too much, okay? let me show you just an example from each of the ones and we'll call it good. So you guys have been great. And this pen taking a little bit longer, but just bear with me a little bit for a little bit longer. Look at number 9 and 10.
Are these on our homework or no?
You'll have, these are on your notes.
Oh,
Let me write it so you can read it. So this is 630 degrees. What's the problem with 630 degrees?
it's like bigger than 360.
It's not on your unit circle, right? But is one of its coterminal angles on there?
Probably.
What would you need to do to find out what the coterminal is?
Minus 360.
There you go. I mean, this is pretty easy to see. It's just going straight down,
Yeah, I'm
right?
like, looks like a 270.
We only have one angle that does that, but just for practice, what you do is you subtract a full rotation, which is 360. Or if it was negative, you would add a rotation, which is 360. And this gives us 270 degrees. At 270, my coordinates are 0, -1.
With X.
So since it's cosine, cosine means let's get the x. So cosine of 630 is 0. And you could check that on your calculator. Oscar, help me out with number 10. How many complete rotations do I have there? It says 855, by the way, if you can't read it. Yeah, what is 2 rotations? It's hard to subtract off. Does anyone know it'd be 360 and another 360, which is 720? All right, great. If I subtract that, I get 135. So Oscar, can you tell me what are my coordinates at 135?
Maybe square root of 2 over 2.
Uh-huh.
Square root of 2 over 2.
And then a positive square root of 2 over 2. Good job. Now, if I'm doing sine, do I want the x or the y? Y, there's your answer. So if it's not on your unit circle, you just make it on your unit circle by subtracting off 360 or subtracting off 720 or adding 360 if it's negative. But what if it's in radians?
Then you turn it into degree. Well,
Then-
then no.
You could do 2 things here. Number 1, you can turn it into degrees by times get by pi over 180. Or you could just subtract off 4 rotations, which is what? What's 1 rotation in radians? 2 pi.
Yeah.
Now, as a clue though, if you look at your unit circle, your radian angles, the only time they're divisible by 4 is if it's right here on the halfway mark. So this angle is actually just 45 degrees. How do I know that? Well, if the denominator is a 4, it's going to be 45, 135, 225, or 350. So you learn some tricks right there. Okay? Or right here, if it's going straight down, what do I know the coordinates are going to be?
270, 0, or...
Yeah, 270, which is 0, -1, and I'd say sine is that guy, right?
And then the 3 is that denominator of 3 on the other one? Is that same
What's
thing?
your question?
For the 3, is that the denominator? I don't know what the denominator
It's 16 pi thirds. So if your denominator's a 3 or a 6, you know it's going to be, so it's going to be, if your denominator is a 3, it's going to be a 60-degree reference angle. If it's a 6, it's going to be a 30. It's kind of opposite. But this one might be a good one for us to practice, because I'm not sure if this is going to be,
60 or 30?
yeah, 120, or sorry, 210 or 240. So what I'm going to do is I'm going to look at this. This was 1 full rotation, 2 full rotations. What is 2 full rotations going to be? 1 was 2 pi, right? So what is 2?
4 pi.
So I want to subtract off.
It's like, oh, that was hard.
However, what's the rule with adding or subtracting fractions, guys? What do they need to
You
have?
have to have the same denominator.
So what this is going to turn into is I'm going to have 16 pi thirds minus 12 pi thirds, which is 16 minus 12, 4 pi thirds.
Whoa.
Is 4 pi thirds, is it in the 3rd quadrant?
Yes.
Does it seem to match up with that?
Yes.
Awesome, so then what are your coordinates at 4 pi, or at 16 pi thirds, which is 4 pi thirds?
Negative 1/2, negative square root of 3 over 3.
And if we're doing sine, which one of those do we want?
So y.
Okay, that's about as hard as it gets, okay? If it's negative, just add on 360 or just add on 2 pi. But the hardest part on this is making sure you can do this, okay? Alright, so I think you already have your assignment, don't you?
I think, yeah, the one.
It says sine and cosine on the unit circle. It's only like 18 problems, or how many problems is it, Jay? 18. So I want you guys to work on this. How can you check your answers?
With the decimals?
With your calculator, but what do you have to check?
The mode.
Make sure your mode is in the right spot. Alright, good job. Let's spend the last few minutes working and I'll be able to check with you if you need.